Okay, I figured I'd do a couple of the examples off today's worksheet with the literal equations. And just to refresh your memory here, literal equations, as I'm setting things up, literal equations are equations in which we're not solving for an actual numerical answer, but oftentimes our answer actually has variables in it. In fact, they always have variables in it. So we're actually not looking for an end of the rainbow number, the magic number of solving the equation, the variable, let's call it x equals 52. That's not going to happen. Instead, you're going to end up with variables in your answer. For example, x equals 52y plus 3z. That's a literal equation. Okay, it's non-numerical. In its actual answer, it has variables. I'm just going to pick a couple. I think we're going to do number 4 and number 6. So here it goes, number 4. Okay, we're under the commandment, the direction, solve this equation for a. And glancing at it, you can see that it has both a's, right? It has a's, where's my guy? A, b, and g. Those are 3 variables. It also has a couple of numbers. It's kind of a mixed bag, this one. It has both variables and numbers. And we just got to clear it out, and we're going to isolate our a. And sometimes these break the rules of how we typically solve the equations before. We take care of the baggage by adding and subtracting, try to isolate our variable we're looking for, combined variables if you need to get variables together, and then divide at the end or reciprocate or multiply. We had a set repeatable pattern for some of our older problems that we've been doing through chapter 2 through section 2.5. But now we're going to have to switch gears here and not really have a set pattern, but use our legal math moves, right? Our eligible math moves that we have here in our toolbox in order to try to get us on the right track. What I mean by that is, as I'm looking at this question number 4, I can see the one thing that's just shooting out my face. If I have to solve for my a, the big problem here, or the big move that I should focus in on, is getting rid of the 3b. Okay, it's a fraction. It's mucked up with the fraction. Fractions are ugly to deal with, but I can easily get rid of that. Okay, if I multiply both sides by 3b, I end up losing my denominator, and now I don't have a fraction. So I'm going to say 3bg. I can put a dot between them. I can just leave it as 3bg. I prefer to leave it as 3bg. Now I have it flattened out, no fractions involved. 3bg equals negative 4a, and then subtracting the 4 minus 4. Again, the whole goal here is they want us to solve for a, so we have to solve for a. Well, now this is very typical to a lot of the problems we've had in chapter 2. We have to clear the quote-unquote, I call it the baggage. The baggage, we can't start working on this term, the negative 4a term, until we get rid of this 4. And getting rid of that negative 4 is quite easy. We can just add a 4 to both sides. Do something to one side, it's got to happen to the other. Get rid of it, it's gone. Okay, and now we have, well, nope, on the left-hand side, we can't add these up. We can't do anything. That's okay. In fact, this is what makes dealing with literal equations actually a little bit easier, because I don't have to get my calculator. I don't have to tax myself on my math, because 3bg plus 4 is 3bg plus 4. There's nothing to do on that. And that now equals our negative 4a. And this is more traditional. In order to clear the a, isolate it, we're going to get rid of the negative 4. This is multiplication, so I have to divide. And if I divide both sides, I get rid of my negative 4, and I just isolated my answer. I apologize, I can't write it underneath. I'm going to write it right here in this box. A equals everything that's left. 3bg plus 4 over negative 4. Now, there's a lot of ways to express this. Some people feel a little uncomfortable having the negative in the bottom there. It's totally okay. You could bring this negative out front. You could also distribute it across the top. I know that's what they do on the key. The key will list this as If you don't mind, I'm actually just going to stretch this box upward. The key would list this as a negative 3bg minus 4 over a positive 4. I will take either answer. Okay, you can express this a couple of different ways. We could also brought the negative out front as a dash in front. Totally acceptable in my mind. If you wanted to see that one, it is a equals negative 3bg plus 4 over 4. So you can see what I did here. I solved for this one. I could bring this negative out in front. That's the top one. Okay, so it kind of goes to in front of the fraction symbolage. Yikers. Or I could put it on the front, the top, I'm sorry, the numerator, and distribute it. All three answers in my mind are legal and acceptable. But in totality, let's just talk about what we did here. Just review. I need to isolate the A, so I wasn't comfortable with the fraction. I said, let's just get rid of it. Multiply both sides by 3b. That canceled out. On the other side here, this doesn't cancel out. It doesn't do anything. It says 3bg, so I write it as 3bg. Okay, don't get confused that there's no number there. In fact, it should be easier this way. That got me down to this line here. I had 3bg equals negative 4 minus the 4. So I said, let's get rid of this baggage, the minus 4. So I added 4 to both sides. Cancels out. Again, there's no math to be done except just combine these terms. 3bg plus 4 is 3bg plus 4. That's it, as far as we can go. And that equaled a negative 4a. Now we're in a position here on step 3 where we can clear out the negative 4 and isolate our a. So I divided both sides. Since it's multiplied, I divided negative 4 to both sides. Got my final answer, which is here, okay, in this box. And don't get confused by the little dot there, which is going to be obnoxious when I go to erase it. All right, so I have this box, which I would take as an answer, or you could take the other two boxes. All three answers are the same. All right, let's do another one here. Let's clear the board, and maybe we'll scroll down to number 6. Let's do number 6. So if I clear the board, scroll down to number 6. Looks like that. Switch colors. Why? Why not? Okay, let's do this one in blue. In my opinion, this is an easier problem. We have negative 3a minus 2 equals wv. Solve it for a. Okay, this is very typical to problems that we've been doing the last few weeks. It's just that we now have extra variables. Instead of just having one variable, we have actually 3. And that's okay. Okay, hopefully that doesn't stress us out too much. I'm trying to isolate this a, the negative 3a. Okay, I'm trying to isolate the a, but I'm going to call it negative 3a. I'm trying to isolate this term, so I'm going to get rid of the negative 2, the quote-unquote baggage. And I'm going to do that by doing the opposite of what's given. It's given as a subtraction, so I'm going to add. That's okay. I can add anything I want to an equation as long as I do it to both sides. So those are gone. I have negative 3a equals wv plus 2 is wv plus 2. I can't break that down any further. I don't need my calculator for that. Okay, it's just as far as it'll go. wv plus 2 is wv plus 2. We don't know the value of w and v, and that's okay. We're not tasked with dealing with that. We're just simplifying this in regards to simplifying it as a equals. Okay, isolating the a. One more step to go. I need to clear out. I have the negative 3a term. I just want it to be an a term. These are multiplied together, so I do the opposite. I divide. When I divide both sides, I end up with that canceling out. The negative 3's are gone. I have my final answer, which is a equals wv plus 2 over negative 3. Just like our last one, you can simplify this one. You can bring the negative out front. Okay, so you have wv plus 2 over positive 3, or you can distribute it across the top. Doesn't matter. So I'd have negative wv minus 2 over 3. All three answers in my mind I'd be taking. Okay. What I need you to get is over this hurdle of, oh my gosh, these aren't numbers, they're hard. Again, it should be easier. Note that we never used our calculator or we never stressed ourselves in order to do some arithmetic from 3rd and 4th grade. We didn't need to do any of that because they weren't actual numbers. They are variables that stood for numbers that we don't have access to, and that's okay. So doing some of this math like adding WV and plus 2, you just add the WV and add the 2. So it's WV plus 2. Okay? Don't get concerned or don't stress out on that. You just have to know that you can't add these because they're not the same term. Okay? They're not like terms. So that's okay. They just stay as put. And the same with the division by 3. Can't really clean that up. The only thing we could do is move that negative around. Okay, and I did that a couple ways, but I'd take all 3 answers. Literal equations, I need them to be not more difficult, but actually easier, and I hope this helps. And I have 11:05, wait for it, 11, let's wait for it, and go!